morning and inviting me back to participate in this segment. One of the things that's very exciting that's gone on is we have now opened our Lenovo System X Center in Waldorf, Germany, and we now have folks in the official Lenovo SAP International Competency Center as well as in the Linux Lab. So this is an important aspect of the evolution of our solution going forward, where we now have an official center in Germany working with SAP directly. And it involves the same fundamental team that was doing x86 SAP solutions at IBM, and they now officially have their own offices, their own center there in Waldorf, Germany, to work directly with SAP. So it's very, very exciting. This gives you an idea of the look at the center, and you can see all the associated folks. Some of them may be familiar to some of you. I can see Mike Gibson, who I believe just recently retired, and a few others, Frank Zimmer, who is a German counterpart of mine, all there participating in the opening of the center in Germany. One of the things that I wanted to talk about and continue to stress with all of you is the absolutely superior design of our hardware solution, allowing us to support easily the next couple of generations of Intel processors. And that's important as we move forward and become closer to the announcement date of the next generation of Intel processors called Haswell. We managed to do this through the use and exploitation of this concept of a modular design, where we use compute books that allow us to easily change out the processor technology that Intel provides us. In this case, the intent is we currently support the Ivy Bridge technology. We'll support the next version of the E7, which is Haswell, and then its follow-on, which is called Broadwell. It also gives us some flexibility when we talk about moving or changing the hardware platform and upgrading from a 4-socket configuration to an 8-socket configuration, where fundamentally all of the modular components that from a 4-socket system can be moved to an 8-socket configuration, assuming you have processors that are capable of operating in an 8-socket environment. It's really quite an outstanding design, and it's far superior to any other offering in the marketplace today. This gives you an idea of the rear of the chassis, where you can see the flexibility we have with primary I/O books and then additional I/O books to expand and extend your PCI slot capabilities, providing customers with a very flexible configuration that's very, very cost effective. You'll also see the 4 power supplies at the bottom. In an 8-socket configuration, you would be able to remove those power supplies from the 4-socket chassis, the 3850, and place them in a 3950, as all of the modular components are interchangeable between the two systems, with the exception of, again, I'll remind you, the processors themselves, where in an 8-socket configuration, you would need to be using the 8000 family of processors. One of the things that's important, again, to stress is that when IBM started working and Lenovo continued to work with SAP on their design, we wanted to keep things simple. Adhere to the idea of a big data kind of model for their HANA solutions, and allow us to not be constrained or restricted by the traditional storage area network on the back end. There's been lots of discussions about TDI, tailored data center integration type solutions, which customers want to exploit their existing back-end storage controllers. What we found is that customers think that they can just easily integrate into those solutions with no concern for the existing workload on those systems, and that is a wrong assumption. Just because the back-end storage controller is certified for a TDI does not mean that you can just simply add servers, HANA servers to the mix, and then suddenly have a certified and validated HANA solution. You have to go through a certification process, and that's critical. That's why we do still believe that the appliance model has a superior approach, not only from a performance and configuration perspective, but also from a support perspective. Because the support is really aligns with the idea of a one throat to choke, where fundamentally your support always starts with SAP in the appliance type of configuration. The other thing that's interesting is that we've been able to seamlessly upgrade our solutions over the course of the last 5 years, where we've been able to not only add new features and functions, including features and functions of GPFS, but also add additional new technology to existing clusters, where we merge X6 technology with X5 technology, and we'll be able to merge Haswell technology with existing Ivy Bridge technology in the X6 family. So this allows us then to seamlessly expand our clusters and integrate new technologies as they become available. And of course, as I've told you before, we've got the largest and most scalable solution available in the marketplace today. We talk about using the appliance model to scale to 56 terabytes. And before the session's over, hopefully we'll talk a little bit about our scale-up capabilities, which are being rolled out to customers as we speak, under a restricted kind of approach that SAP is controlling. So we'll talk a little bit about that. I'll hint to what that is, but I can't give you any more details. It requires a non-disclosure. So if you're interested in what our scale-up solution would look like, please contact me, and we can chat about that a little bit going forward. One of the things that I wanted to talk about is the importance of large memory configurations, not only from a scale-out perspective, but a scale-up perspective, and look at the technology, the various technologies as we move forward, and then do a quick summary on the call. So let's chat a little bit about this idea of large memory configurations. And when I talk about this, I'm not talking about 1 terabyte systems. Frankly, even 2 terabyte systems, although those are really quite large. I'm really talking about 6 terabytes, 12 terabytes, 24 terabytes, and even larger configurations where it looks like and acts like a single system image, whether it be in a scale-out environment or whether it be in a single standalone node. So let's talk about that. One of the things and one of the challenges that customers are faced with today is the multitude of sources of data. Now, the thing that I'd like to point out is that until you do something with that, it's just data. It's just ones and zeros. It really doesn't represent any value to a company. So when you look at data, regardless of whether it's small or large, because remember, to some companies, a small amount of data collected appropriately can be critical to their business. And in other cases, large amounts of data where customers can sift through it and find hints to what's going to happen is critical. But that data needs to be acted upon. It needs to be analyzed and turned into information. Information that then can lead to insight. Insight is actionable. And that's where you get to the point where now a customer can do something with that data. And when you look at the volumes of data coming from all kinds of different sources, and think of the volumes of data that exist within social media that really can be analyzed and used successfully. Recognize that that kind of data, social media data, has a limited value or a limited lifespan of value, where it needs to be analyzed quickly and immediately, because in the next 10 minutes it may not have any value or immediate value that can allow you to take action on that information. So it becomes critical on how quickly you can analyze this data and give you something that's worthwhile to take action against. So when we talk about big data solutions, we can be talking about megabytes in some cases, and years ago megabytes was a big data solution. But that's transitioned into gigabytes, onto terabytes, and to petabytes and even beyond. And when we begin to realize the volume of data we're looking at, traditional approaches now become a real challenge. And we've seen things emerge in the marketplace that are critical to being able to look at these true big data solutions. HANA happens to be one of them. HANA, in conjunction with, as an example, things like Hadoop, can be critical. IBM has some fantastic solutions in the big data area. And so when we begin to look at that and consider that, we need to look at how you can tackle that and even integrate it into a traditional enterprise data warehouse environment. So those scenarios are great, and you can look at that, big data solutions, as being a traditional enterprise data warehouse. But there's also another thing, large-scale data marts that are really a specific subset of data, but are large volumes of data critical to the business and need to be analyzed very, very quickly. And when you look at, as an example, the SAP Business Suite, large companies, large data, and they need a real-time view of their operational functions within the organization, whether it be immediate sales, immediate inventory volumes, where things are occurring, where trucks are residing in terms of shipping. Those kinds of things become critical to a business, and they all participate generally in the SAP Business Suite as opposed to a traditional enterprise data warehouse. So when you look at the Business Suite, it acts a little bit differently, looks at more at real-time kinds of situations than does a traditional enterprise data warehouse or SAP's business warehouse solution. One of the important aspects of large memory configurations is a customer's ability to merge the data into a manageable size. Even if you're looking at petabytes of data, many times you need to filter, sift, and come up with the data that's worthwhile looking at. So the idea of merging data, managing that data in a way that you selectively bring in or read or collect the data, and then your ability to analyze that in real time in such a way that it allows you to assess its impact on the business and assess what kind of action you can take based on your understanding and insight of the data that you've analyzed. So let's talk a little bit about our Scaleout solution, because this is traditionally where Lenovo has offered a far superior, has a far superior offering to anybody else in the marketplace. The one thing I want to point out is the approach that we take in this scenario. Again, we use an IBM product, IBM's general parallel file system, specifically the file placement optimizer version. And the reason this is important is because it really eliminates that back-end bottleneck associated with traditional storage controllers. The way we do that, and if you look at the picture starting point, you see that it's more or less like a traditional storage controller. But when you begin to collapse this environment, move the storage into the local nodes, eliminate the controllers on the back end as the thing, you now begin to see where I now have collapsed this environment into what I describe as a true converged infrastructure, where now I exploit all of the network and I/O capacity of each individual node and eliminate the restrictions associated with that back-end storage controller, creating, in essence, a really truly converged infrastructure where I'm using Ethernet connectivity, specifically 10 gigabit Ethernet connectivity on the back end to create my database cluster to support this scale-out environment that we described. And really, when you begin to analyze this, we really have no true limits on the amount of data or capacity that we can support within this environment. IBM and SAP really created the first petabyte in-memory database, and frankly, it's gone well beyond a petabyte these days. And that was what was described as a 100 terabyte solution that we demonstrated in 2012 at Sapphire. That actually grew to 150 terabytes, and when you do the mathematical numbers and go through the compression algorithms that SAP has, that really represented more than a petabyte of compressed data that resided in the 100 terabytes of memory available to the HANA database. So our scale-out solutions, when we look at the scale-out solutions, we have several different options for customers. And the smallest that we can start with is a 256 gig configuration. It uses 2 processors in an X3850 configuration and can scale all the way out to 4 nodes. This is really for small environments where a customer really has a good handle on how large their configuration is going to grow. We typically don't sell many of these because many times customers would rather start with a little bit larger configuration that provides them more headroom and more flexibility in scaling the solution beyond the 4-node limitation that you see on this 256 gig configuration. When you go to the larger configuration, at the 512 gig configuration, you see that our configurations become very, very consistent across the board. In this case, we're using 4 8880 processors with 512 gig. There's 4 solid-state drives and 15 1.2 terabyte disk drives in this configuration. And this configuration can scale out to 56 nodes. So you can do the math on that, but I believe that's 28 terabytes of memory. And it's a very, very large capacity environment, but recognize 56 nodes is a lot to manage. So if you look to the right of that, as you begin to look at larger configurations, we can do the same thing with 1 terabyte nodes and out to 56. So now, of course, we're at 56 terabytes. And then we can go into configurations that even provide more flexibility. And I'm not really showing all of the options that are available to customers here, only the most commonly used one. In this case, we have an 8-socket configuration. And you'll note that in this case, we don't need the EXP2524, the storage expansion unit, because we have enough disk drive capacity internal to the 3950 to be able to support the storage capacity required for what's described by SAP as the persistence layer. So in this case, we can, again, keep it inside a single chassis and grow the configuration all the way to 56 nodes or 56 terabytes. When you go to a 2 terabyte configuration, we do have to add the EXP2524, again, to adhere to SAP's requirements for storage. But again, we can now go to 56 nodes, which is 112 terabytes. Now, we are certified in this solution, so a customer can do this without asking for any assistance or blessing from SAP. So it's a very straightforward kind of configuration that allows us to grow this cluster seamlessly and non-disruptively. So on the next chart, we'll talk a little bit about the systems that are for scale up only. Now, this is a little bit different and targeted at SAP's Business Suite. The previous set of charts are really the analytics-based solutions that are targeted for SAP Business Warehouse, and there are other analytics solutions that typically fall into the sidecar kind of category, where they're doing lots of analytics work and extracting data from a core Business Suite family of products. In this case, these solutions are designed specifically for the Business Suite. Now, on the previous chart, all of those systems can be used with the Business Suite. These systems that I'm showing on this page can only be used with the Business Suite. They cannot be used for large scale-out configurations. This is important differentiation because it's critical that you understand the customer's use case and know the limitations and restrictions of which system is appropriate for which scenario. So again, the previous set of configurations will work for the Business Suite, the transactional systems, and with BW or analytics scale-out solutions. This set of charts and these configurations will only work with the Business Suite. So you'll see that the memory to core ratio, or the memory supported by the number of processors in the system, is basically twice as large as in the previous configurations, where we can have a 4-socket system with 4 E7 processors supporting up to 2 terabytes, and then we have 8 processor systems that can support 2, 4, or even up to 6 terabytes of memory in the system. Along with that, we have an option that's not been certified for production by SAP that is a 12 terabyte solution. We're working with them, and in some scenarios, we've had their blessing to use and test this 12 terabyte solution. Again, it's an 8-socket system with 12 terabytes. It uses 64 gig DIMMs, so it's not necessarily an inexpensive solution, but it does work, and it does work very well. We have, at this point in time, some comparative information against some of our competitors' 16-socket solutions with 12 terabytes in their solutions, and we found that fundamentally there is little or no performance difference between our 8-socket 12 terabyte solution and their 16-socket, 16-processor 12 terabyte solution. We're continuing to do further testing. This is with at a customer site with customer data, so it's very, very legitimate kind of testing, and we'll keep you posted as to the progress there. But we're very, very pleased with the results of the performance of our system and the low latency that this 8-socket system provides that really delivers outstanding performance. So we're very convinced that in a 6 terabyte configuration, not only do we perform well, but we also will deliver better value than our competitors. And when you go to an 8-socket system with 12 terabytes, we're very confident that we can really deliver outstanding value to our customers in the Business Suite. Now, we'll talk a little bit more about these scale-up solutions. These are considered our scale-up solutions at this point in time. We'll talk a little bit more about some things that are coming soon and in a bit. One of the things I want to point out is how we do our scale-out environments so that you understand this and how unique this is in the industry today. If you look at this chart, you'll see that there's the primary data that's part of a storage pool. There's where the data files and the log files are stored. Then there is the first replica of that data that occurs in or across the other members of the cluster. Each node owns and manages its own data, and that's done by GPFS. And GPFS creates a striped replica of that data across the other members of the cluster. This creates I think you can describe it as a RAID 10 sort of configuration, where locally each node uses a RAID 5 configuration for its data and logs, and the replica is then striped across the other members of the cluster, creating a RAID 10 sort of configuration, if you want to think of it like that. I really am not quite sure how to describe it, but when you see the way this operates, and I'll show you that now as we go through this chart, when a node fails, HANA identifies that failure and begins the process of reconstituting the standby node that's on the right into the new, in essence, member of the cluster that's the failed node. So when that happens, GPFS just simply begins to reconstitute the memory of the failed node on the standby node by reading the failed node's data from the replica in the file system. Now, the interesting part about this is very, very fast in terms of failover, because we're not worrying about things like SCSI-3 persistent reserve, where you've got the failed node has to release its hold on a given LUN in the storage environment. We don't have to worry about that. This is a global file system where all of the nodes can read and write to all of the other nodes' disks. And so consequently, the standby node can very, very quickly begin the process of reconstituting the memory of the failed node. Once that occurs, you see that the actual workload transitions over to the standby node, and you now have recovered the cluster and done it very, very quickly. Mostly transparent to the user, other than they may be waiting on a query temporarily while that node rebuilds the data. And recognize that the cluster never really becomes unavailable. It's just that certain queries requiring the data on a failed node may pause or delay their response until that standby node has fully recovered and become the new node 2, in this case, in the cluster. We take how we use GPFS very seriously, and when in large clusters, we can create failure groups where we limit the distance or the number of nodes that the data is striped across, and for each one of those failure groups, we can have an individual standby server to support that environment. This allows us then to have a very, very reliable cluster. Granted, we still can only tolerate one failure within a failure group, but it does give you the option within the overall cluster to improve the reliability slightly by being able to have multiple failure groups, each of which can tolerate a concurrent failure, a single concurrent failure. So let's talk a little bit about the scale up. And we talked a little bit about it earlier. We do have a broad range of different options for customers, from 2 sockets to 4 sockets and on to 8 sockets, and multiple memory configurations depending on what a customer needs done. As an example, although it's not shown in this chart, in a scale-up scenario, we can do a 4-processor configuration in an 8-socket chassis supporting 1 or 2 terabytes of memory, allowing a customer then a lower cost entry into a large configuration that can be upgraded in the future. It's not shown on this chart, but that's one of the options and one of the flexibilities we have within our configuration. It also can, in some scenarios, eliminate the requirement for the external EXP2524, improving the reliability of the solution slightly because you eliminate that cable, that SAS cable between the 5120 serve rate adapter and the EXP2524. So there's several different options that we have in this scenario. And again, they can go to large configurations, as we mentioned earlier. So I showed you a little bit more of the details in the scale-up scenario here so that you have an idea of how these configurations can work. And please recognize that there is overlap between the scale-out configurations and the scale-up configurations. Some of the scale-out configurations can also be used with the business suite as a scale-up configuration. This is what's interesting about our configuration, because if you start off with doing some work with the BW environment, you create a sandbox, it may very well be possible to reuse those nodes as your HANA projects evolve into the business suite, where then you can reuse those nodes from the sandbox in the BW or scale-out environment, reuse those nodes in or with the business suite in the future. And this is really kind of an outstanding approach and pretty much unique in the industry in some ways. Most of the competitive scale-out solutions are going to require a back-end storage environment. We don't have that requirement. Also want to point out, in a TDI scenario, we can integrate external storage in this environment very easily. These configurations would look on the surface to be hard and fast, but we can add additional 10 gig adapters if a customer requirement, additional 1 gig adapters if a customer requirements, and maybe most importantly, host bus adapters if a customer requires connectivity to their back-end storage controllers through a storage area network. One of the things that's been interesting about the X6 solutions is that we can take a 3950 and split it into fundamentally 2 halves, where we can use each half for as a separate server. Granted, there is a slight performance degradation, but we allow, and SAP allows this flexibility to, it's called the Flex node, to be able to support a couple of production environments as separate entities, including separate OSs. So it's kind of a nice option if customers need that sort of configuration and want that flexibility of being able to eventually re-merge the systems into a large configuration for a different kind of environment that they may need to support in the future. So let's talk about technology a bit, because this is one of the more interesting aspects of today's discussion. And I think it's important that we have this discussion, because there are several different things that are occurring that you need to be aware of. First, in the October-November timeframe last year, the Lenovo HANA development team certified GPFS 4.1's encryption technology. This is an important aspect for customers who are really concerned about the security of their data. Now, the encryption technology is only available in the GPFS advanced version of the license today. We're working to have that available in the standalone server version, and we're hoping that we can convince IBM to add it as a more standard feature in the standard version of GPFS that we currently use in our HANA offerings. However, if we need to do this upgrade to the advanced version, we can do that for customers that require this. The reason this is important is this technology meets several levels of government and industry standard requirements that are unavailable from any other offering, including SAP's own encryption technology of the database. So this takes it to another layer where you can exploit this technology in a scale-out cluster such that the data moving between nodes via the GPFS file system is completely encrypted on the Ethernet connections. All the backups are encrypted as well. And if you look at deletion as an example, you really can't arbitrarily delete things. There's no, you can't even digitally shred the system. You have to do it through, in essence, it's secure based on the cryptographic algorithms that are used. So when you look at how this actually works, you begin to see that there's an external key server that provides the key. None of the keys for the encryption technology are stored locally. So it really, truly is a very, very secure environment, and it meets the, as I suggested, the NIST and the FIPS requirements and compliance, so that you really do have a truly secure environment. When you combine that with SAP's encryption technology, you have the best of all worlds. Now, I think this can be important and critical for some customers, of course not for all. And customers that need this kind of security, I think would be more than interested in at least looking at and evaluating this technology. It really is quite outstanding and can really address some of the security issues that have been problematic for HANA over the course of the last 5 years. And when I say that, it's really around data security and encryption. It's not the database itself. It's just, this fills in a gap that has been unavailable. And there's no other file system that I know of that provides this level of encryption and or security. So let's talk a little bit about some of the future technologies. We know, I'm hoping we all know, that we're on the cusp of a new Intel processor called Haswell. The latest rumors suggest that it will have 18 cores per socket, and with that increase in the number of cores, you would expect that SAP would support larger memory configurations. Well, I'll just say that that remains to be seen. The latest rumors coming from SAP are that that may not be the case with the Haswell systems, and consequently there's going to be some disappointment among customers who are expecting larger memory configurations with the introduction of Haswell. So we're trying to get more information on exactly how much additional memory SAP may or may not support with the new Haswell processors, but that again remains to be seen. We do know that with the introduction of Haswell, sometime later this year, the systems will support DDR4 memory, which then will allow DIMMs of 128 gig. This should have an impact on the pricing of the 64 gig DIMMs that are DDR3. The systems, the Haswell processor will support either DDR3 or DDR4. I'm not sure if you can mix. I suspect you can't mix DDR3 and DDR4 in the same system, but here and there, the fact that we will now have 128 gig DIMMs will obviously drive down the cost of 64 gig DIMMs and consequently drive down the cost of 32 gig DIMMs. This is historically the way things have worked, and we expect that 32 gig DIMMs will probably become the new sweet spot for DIMM cost. Realize that Haswell does not change the number of DIMM slots available per processor. That will remain at 24. Consequently, you have to keep that in mind when you're considering these larger DIMM sizes, and realize that you're still restricted to the number of DIMM slots. So you can look at what's the most cost-effective solution for a customer and target the memory size appropriately. We're still expecting non-volatile memory to become available at some point in time. Flash DIMMs are still being worked on, and we're expecting that work to continue. But we also expect new technologies to take this idea of non-volatile memory a step further in the future. And the question always comes about is, why would 6 terabytes, 8 terabytes, 12 terabytes not be enough memory? Well, going back to some of the things that we talked about earlier, the data sources are increasing. The volume of data that needs to be analyzed is increasing. We're looking at SAP and their new technology that they describe as S4, that's more or less designed to really truly exploit all the capabilities of HANA as their new ERP system, and that solution's ability to consolidate many of the traditional SAP components into applications that run against a singular database that would require, obviously, more space for data. And so we see that the data volume and consequently the memory required by systems is going to only increase over time. And when customers begin to realize the value of real-time data analysis and their ability to identify trends instantaneously and take action against those trends, and they're going to realize that these large memory configurations really truly do bring an incredible value to the enterprise. Also, when you begin to look at the memory capacities of these systems and how they can be used, you begin to realize customers can take a broader approach to the whole concept of big data, where with Hadoop, and you may have 100 or 1,000 nodes in a Hadoop cluster. Well, if we can have larger memory configurations in systems, why wouldn't we want to reduce that 1,000 nodes down to 100 or down to 50 or even to 20 if we could? This simplifies the overall management and administration of the environment, yet gives you the same kind of data volume and performance and throughput of these very, very large clusters, really making it much easier to manage and support. So you can see why these large memory configurations can be critical to the overall growth of the enterprise and its ability to look at volumes of data much more efficiently and effectively. So how do we address this kind of situation cost effectively? Well, that's an interesting thing. And so one of the things that we've been focused on is staying with industry standards. Follow the Intel processor roadmap. And the reason this is key is when you veer far from that, you find yourself forced into a scenario where you have to recover your investment dollars in a very, very short period of time. If all of you were around back in the days of the IBM technology, we had a 16-socket configuration where we had built a custom memory controller to support this environment. The challenge was we spent tens of millions of dollars on that development process and had to recoup that investment in the course of about 3 years, maybe a little bit longer, because Intel took the concepts and the technology and in some ways probably some of the intellectual property, because we shared intellectual property with Intel, and incorporated it into their own technology. So veering very far from the Intel roadmap ends up being an economical issue that can be very, very challenging to overcome. I like to describe it as no matter how hard you try, you really can't outrun Intel. You can only stay ahead of them for a period of time, so it's like running a marathon. And you can bet that Intel is always going to be nipping at your heels, and they always have the gas at the end of the race to simply run in front of you and win. So by staying with the industry standards and the Intel roadmap, we believe that in the long term we're going to have much better success and deliver much more cost-effective solutions for our customers. Along with that, we view that, let's take a different view of virtualization. And when I say that, this is for the scale-up solutions that we have. And I'm not describing something that's different than VMware. I'm going to describe something that's different, period. And I describe it as a different view of virtualization because it's a different technology designed to do different things than VMware does today. But most importantly, stay focused on this idea of simplicity, manageability, and flexibility. So when you think of virtualization today, you typically think of a single machine or a cluster of individual machines that's optimized towards hardware utilization, meaning that we want to drive utilization of these systems right to the max, using VMware, creating virtual machines on a given machine to drive the hardware utilization through the roof. So multiple machines, multiple virtual machines on a single individual machine that provide this single, simplified single point of systems management, even when you have multiple of these environments in a VMware cluster or a virtual cluster in general. The point here is that the virtual machine generally doesn't span multiple nodes. It resides on an individual piece of hardware within the cluster. But what happens, so this is the kind of look that you have, where the hypervisor is now driving or supporting multiple virtual machines underneath that single system image. And you create a management tool that can look at all those machines concurrently and move workloads around, but the workloads all represent a single element within the environment. So what happens if we take a little bit different view of virtualization? As a matter of fact, we don't really call it virtualization per se, we call it aggregation. And we take multiple systems and we aggregate them into a single system view via what I describe as a distributed hypervisor, where this hypervisor looks like, acts like, and is managed as a single element, a single operating system, now with memory completely virtualized across the entire set of nodes that are part of the aggregated cluster. So now we virtualize the memory into extremely large configurations where we can actually even go greater than 128 terabytes in a configuration. We aggregate the cores across multiple physical machines, and we provide a level of flexibility within our existing building block approach that we saw earlier, allowing customers now to create a scale-up environment using this technology that now creates a single system image that can support all kinds of different applications. It simplifies the management of the environment, and it gives you a single point of management for all the entities that are participating in the environment. So when you see this now, it looks more like this, where we fundamentally take a virtual machine and it now includes multiple physical machines that are aggregated to look like a single system image with a single OS spanning all of those nodes. So now we can create very large single system memory configurations all the way up to like 128 terabytes. And this is something that we're working on. We're working with SAP. We're working with other vendors to use this as an approach to creating large single system memory configurations to address this large data volume and large memory solution kind of scenario while staying within the standards that Intel has available today. And this allows us then the flexibility to use our existing building blocks as a core part of that approach, and we believe we can deliver fundamentally the same performance and throughput of our competitors while using standard building blocks that we've had around for the last 5 years. Of course, we'd be focused exclusively on the X6 technology, but we believe that we can do this. Now, the connectivity between nodes is InfiniBand, very high performance, multiple InfiniBand connections between nodes, but it's very, very high performance, and frankly, we believe it can be very, very reliable. So there's, let's see, there's some additional information. Let's see, oops. Well. There are some additional things that I wanted to talk to you about, and I don't know what happened to them in the deck. So we talked about GPFS and the encryption technology. We talked about our scale-up technology that we're continuing to test and evaluate with SAP. And there was one other thing that I did want to talk to you about that somehow got dropped from this deck, and that's my problem, and that was the idea of multi-tenancy from SAP. Multi-tenancy is where, in essence, you have multiple database elements sharing the same system and the same underlying HANA code. This is a form of virtualization that allows you to containerize a given application's data sets within a single HANA appliance and or database, where now you can run multiple SAP components concurrently under the same HANA database. Now, the challenge with this is that they do share the same HANA code, which means that when you go to do maintenance on the HANA code, you are fundamentally maintaining or upgrading the HANA code for all of the components that are using that database. So it becomes a little bit tricky on how you manage that, but it's an offering that SAP has that allows them then to begin the process of merging their existing application suite to look more like applications than independent entities, where now they share the common database underneath. Over time, we expect that they will even go to the point of sharing common schema, so that now the differentiation between supply chain management and enterprise resource planning and supply chain management and supplier relationship management all begin, and even business warehouse, all begin to look more like applications as opposed to separate individual entities. And since they share common data and a common database, you can see where they would be more real-time than anything SAP has been able to deliver in the past. So with that said, I'm sorry there was only 2 charts on that in the deck, and I don't know what happened to them. I apologize for them not being there. But with that said, you know, Ben, we can kind of do a quick summary, and then we can open up the lines if you'd like. But the one thing I want to point out is we provide unparalleled scalability in our solution. And one of the things that we're noted for is keeping this very, very simple, providing a single point of management for all systems across the entire landscape, whether it be a scale-out configuration or a scale-up configuration. Everything we do is based on industry standards. And when I really say that, I'm really referring to a standard Intel roadmap that is required. And we're really trying to most efficiently address customer requirements. And even in a scenario where customers have requested tailored data centers, we can easily take our appliance model, shrink it down to the minimum requirements that are required for a TDI, and offer that to customers. We're also working on an option where I would call the offering a hybrid appliance model that integrates as a TDI, where fundamentally we stay with the appliance model, allowing customers to take advantage of that support structure, and yet integrating seamlessly with their back-end storage environment. The reason this is critical is TDI really, from a customer perspective, allows customers to integrate with their traditional operational processes and procedures. This really saves customers money on the operational side, and that's really key when you consider things like backup and recovery and creating images of existing production systems or snapshots of production systems, and most importantly, creating DR solutions that are integrated into the existing set of processes and procedures that customers use, so they don't have to have one-off solutions in those areas. So, Ben, we can open this up. I haven't been paying attention if there was any questions that came through. As a presenter, it's pretty rough to do that.
Yeah, no, absolutely. That's fine. Yeah, thanks, Rich. Great presentation as always. We don't have any questions at this time. I'll remind everybody that if you do have a question, please post it in the chat window. You know, I just want to mention that our part numbers had changed a little bit going from IBM to Lenovo. So the slide deck that is available for download has been updated to the new 6241 part numbers. You know, Rich is always available for deeper dives. So if you, as a customer, would like to discuss your environment and how we might be able to improve on it or help you gain performance in your SAP environment, please do reach out to your local Lenovo contact, and we'll get Rich engaged. We don't see any more questions coming through. I will also mention that next month we're looking at most likely the 26th of March for the next virtual user group. We hope to have VMware on the line with us at that point. And then if you have any suggestions for future virtual user group discussions or topics, please do send in your request to x86UG@lenovo.com. Again, that's x86UG as in user group at lenovo.com. Okay. Well, it looks like you must have answered everybody's questions throughout your presentation, Rich, so we don't have any questions coming through. At this kind of time, we'll go ahead and conclude the call, unless, Rich, you have anything else to add?
No, and again, anybody that wants to reach out to me, I'm sure you have my email address, and feel free to do that. I'll be glad to answer any questions that you may have.
All right. Well, thanks, everybody, for attending, and Rich, thanks again for your time.
Thanks, everybody.
Have a good day.
Bye-bye.